Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, we will be calculating the net electrostatic force exerted by a charge. The only difference right now, guys, as compared to the previous video, is that now we are calculating the electrostatic force if the charges are placed in two dimensions. So we can all see that both charges A and B are on a vertical dimension, and charges B and C are on a horizontal dimension. Are you together? So over here, I want to calculate the net force exerted on charge B. So before I do that, I need to know how is charge B going to behave. This will represent my charge B. This will show the force between the electrostatic force between charges A and B. Remember that, guys, these two are just attracting one another. Are you together? And whenever they're attracting one another, that means they will move towards one another. Are you together? But my main focus is on charge B. So charge B will move downwards. Are you together? Or charge B will move towards south as a result of charge A. Now let's check the relationship between charges B and C. Both charges have the same polarity. They are both positive. So they will repel one another. In simple terms, they will just push one another away. Are we together? So this over here illustrates the force that exists between charges B and C. Are we together? But obviously, guys, before we even draw our resultant force, we must always think of a parallelogram. Are you together? The most important properties of a parallelogram is that the opposite sides of a parallelogram are parallel, which means they move in the same direction, and equal. Are you together? So if I can draw the components of this force over there, I'll draw it like this. Are you together? And this will also illustrate the force between charges B and C. Are you together? And then for the other one, I'll draw it like that as well. And this will illustrate the force between charges A and B. Why? Because opposite sides of a parallelogram are equal and parallel. That means they move in the same direction and they are equal. Are you together? So this force is equal to this force, both in magnitude and direction. That force is equal to that force, both in magnitude and direction. Yeah? So for me to draw, for me rather to be able to calculate F net, I must have a triangular diagram like this. Are you together? So I can choose either one of these triangles, né? But let me go for this one, and then we'll call that angle over there angle theta. Are you together? So over here I have my F net. Are you together? But if, guys, you just want to draw your free body diagram without thinking of parallelogram, it's very, very simple, né? Yes, it will be like this, né? But let me show you what to do. Firstly, we want to check the relationship between both A and B, right? But we are focusing on B, so B will be pulled downwards. Are you together? From head to tail, from head to tail, and we are moving from the head of both charges of the force that exists between A and B, and then we'll start our head over there. Are you together? This will show the force that exists between charges B and C over there, né? So since it's a repulsive force, that means B will be pushed towards the left. So this will show the force between charges B and C. And then our resultant force will just be like this. and then you draw your angle theta over there. Né? Let's do another example. Let's say you have charges. Let's say you have charges like this. You have a negative charge, a positive charge, and a negative charge over there. Né? Let me just say negative 6 coulombs, negative 7 coulombs, positive 7 coulombs. You want to calculate, or rather, you want to check the behavior of charge X. That's X, that's Y, and that's Z. Né? I'm focused on the behavior of charge X. Firstly, I will check how is charge X going to behave as a result of charge Y. Excuse me, both charges are negative, so they will definitely repel one another. So charge X will be pushed upwards like this, né? And then I'll start right there to check the relationship between X and Z. X and Z are attracting one another, so X will be pulled towards the right. So this will be the force that exists between charges X and Z. That's the force between charges X and Y. And then my resultant force will just go like that. This will be my F net. Are you together? So that's how, guys, you just draw your free body diagram. Yeah? It's very, very simple. Okay, let's go to our question. Let's go back to our question. Let's go back to our question. Okay, so now they want us to calculate the net resultant force. Are you together? For us to find the net resultant force, we can see that we have a right angle triangle over there. That's 90 degrees. Are you together? If that's my angle theta, that means this over here is my opposite, and that over there is my adjacent side. Are you together? And obviously the side which is opposite the 90 degrees is always called hypotenuse. So for me to determine the direction of my resultant force, I must go and use my trig ratios. Né? But don't worry, guys, we'll fix that when we get there. So the force that exists between both charges A and B, it's simply KQA times QB over R squared. That's 9 times 10 to the power 9 multiplied by 4 times 10 to the power negative 6 and 3 times 10 to the power negative 6 all over 0.5 squared. Let's see what we get. 9 times 10 to the power 9, 4 times 10 to the power negative 6, 3 times 10 to the power negative 6, all over 0.5 squared. So this will basically give us 0.432 newtons. Are you together? Let me write it there because you don't have space. This is just 0.432 newtons, né? But remember, guys, I'm focusing on the electrostatic force that exists between both A and B, né? This force will kinda force charge B to move towards the south. Are you together? Then now let's go and calculate the force that exists between charges B and C. That's KQB and QC over R squared. We have 9 times 10 to the power 9. We have 3 times 10 to the power negative 6 and 2 times 10 to the power negative 6 all over 0.6 squared. And then 9 times 10 to the 9, 3 times 10 to the negative 6, then I have 2 times 10 to the negative 6 all over 0.6 squared. and then that will give me 0.15 newtons. Are you together? So this force over here kind of forces charge B, not kinda, it forces charge B to move towards the west or towards the left. Are you together? And then for me to find my resultant force, I have a situation like this. Okay, let me redraw this force diagram of mine. I have a situation like this. I have 0.432 over there, 0.15 over here. For me to find the hypotenuse, I just need to go and use Pythagoras theorem. Are you together? So Pythagoras theorem simply says F net squared is basically equal to the force that exists between A and B squared plus the force that exists between B and C all squared, right? I simply have 0.432 squared plus 0.15 squared. That's F net squared. So for me to find F net, I just need to say, I just need to put the square root on both sides first, ne? I have 0.432 squared plus 0.15 squared, and all of this is under the square root. I'll simply get 0.46 newtons. If they said to me, calculate the magnitude of the resultant force, I would have been done here, ne? But they just said calculate the net electrostatic force. So I must give both magnitude and direction. Why? Because force is a vector quantity. Are you together? That's 0.46 newtons. Okay, remember that, guys, my angle theta was somewhere there. Are you together? So for me to write down the direction, I just need to find angle theta first, ne? I will refrain from in this question, guys, ne? Yes, I know that you can use any trig ratio because you have both opposite to the angle, adjacent to the angle, and the hypotenuse. I know you can use your SOHCAHTOA, you can use any trig ratio you prefer. But just because I've rounded off this ants over here, I'm not going to use either cos or sine because they will require me to use my hypotenuse. Are you together? So for me to find angle theta, I'll simply use tan. I know that tan theta is equal to opposite, whatever that is opposite the angle, divided by whatever that is adjacent to the angle. Are you together? So I know that for me to find the angle theta, I simply need to say tan of my theta is just opposite, and the opposite part is represented by the force between charges B and C. The adjacent is just the force between A and B. So tan theta is just 0.15 all over 0.432. Are you together? And therefore theta is just the inverse of tan 0.15 divided by 0.432. Then I'll go and find my angle. Shift tan 0.15 all over 0.432. This will give me an angle of 19.19 degrees. 19.19 degrees. Ne? So whenever, guys, I write my final answer, I'll simply say, remember that the 19.19 degrees is over there. Ne? So firstly, I'll simply say south. The direction of my force is south. However, it is just 19.19 degrees to the west of south. That's how, guys, you're supposed to calculate your. That's how you're supposed to calculate your your electrostatic force, né? So direction, guys, is very, very important, né? Remember, with guys, this angle, it's just theta degrees away from south. Are you together? This was the direction, but it will go towards the south as well at that angle over there. So how to calculate this? Simply say 0.46 newtons south, 19.19 degrees west. That's how, guys, we're supposed to tackle this question over there. Né? Whenever you deal with forces in two dimensions, that's how you need to calculate. But they would hardly ask you to find the direction. But if they do ask you to find the direction, this is this is how you express the direction over there. How it's get. But in most cases, they just want you to find the magnitude. So by just doing this, you will be okay. Yeah, just stay tuned, guys, and wait for more videos.